Again, thank you everyone for joining me today. My name is Chris Dubuque. I'm one of the application engineers for computer-aided technology, and we're going to be taking a look at some pretty cool functionality today, the free and powerful SOLIDWORKS Express tools. Now, I do have to give credit where it's due. This content was put together by Justin Maxwell and Judy Marlowe, a couple of application engineers in the Central and Eastern time zones with computer-aided technology. They've given this presentation at SOLIDWORKS World. It was quite popular, so I wanted to give everyone a chance to see the content because not everyone gets to go to SOLIDWORKS World. So let's talk about this. So the SOLIDWORKS Express tools, what are they and how do we use them? That's really what we're going to go through this morning. Starting with Driveworks Express, then we'll go through the DFM Express tool or designed for manufacturing, Simulation Express, and wrapping up at the end for FlowExpress. So these particular tools, there are, as you can see up on the screen, 4 of them. And they're really a sample of the full application, the full add-in that you could purchase. So for example, Simulation Express is a simplified version of full SOLIDWORKS simulation. Sometimes people refer to them as teasers, but while they do have limited functionality, they're built on the same technology. So again, using Simulation Express as an example, it uses the exact same meshing technology and the same linear analysis solver that the full simulation software uses. FlowExpress, again, uses the same mesher, the same CFD solver that full-blown flow simulation uses. So while, yes, they are simple, there's a lot of horsepower that's available as long as you know the rules of these pieces of software and when they're, the most applicable to use. So the first thing that we need to understand about the SOLIDWORKS Express tools is this screen right here. And if you've ever tried to use one of these, you've seen it, and that is the need to request an activation code. All 4 of them will require a unique code. It's at my.solidworks.com/express. You can see the URL up there on the screen. And you must have a SOLIDWORKS customer portal account. That's so you can get into My SOLIDWORKS. So the way that this works here is when you go to start one of these Express tools for the very first time, for example, Driveworks Express, click the link and your web browser will open up to my.solidworks.com and you can go ahead and log in. Now the software automatically captures your SOLIDWORKS serial number and will populate the field and copy and paste that activation code. It says view other products there. You could grab that drop-down list and get every single activation code in one step. You only need to do this for each major release, the first time you run them. After that, they should be activated every single time. Of course, if you have any questions or issues with any of this activation capabilities or whatnot, always give us a call here on tech support. This is a pretty common thing that we go through and help people out with that. But that's step number 1. We must get them active. So once it's activated, let's talk about Driveworks Express. What is Driveworks Express all about? Well, it's a simplified version of full-blown Driveworks, which is a knowledge-based engineering tool. This allows us to create those same but different designs. For example, the framing of that shed up on the screen. We might have a design with a steeper roof pitch, a shallower roof pitch, a larger floor area footprint, a larger door, a smaller door, maybe with a window, without a window. You get the idea. So it really allows us to capture these rules and streamline this process. The most important thing about all of these tools, though, is they're free. We all have access to these pieces of software. So maybe you've been a little bit hesitant to turn one on and see what it does. If nothing else, it's all about sharing the information. You can see what they do and see if they're going to be useful for you. Now we're going to use an example of a door. This is the door to the shed, and we'll go through and basically take this model all the way through leveraging Driveworks Express. So this is what Driveworks Express can do when it's completely set up. And this is using the model of the entire shed. It runs over in the task pane on the right, and we get this easy to understand form that has the rules and the logic and the database built into it. And all we need to do is just specify a few numerical parameters, maybe checkbox options if they happen to be there, and then Driveworks Express will create a new model for us. Once everything's valid, the little create button is available. We click it. It does use a seed part model, and you'll see it jump on the screen and then geometrically change to the modified version of the shed. So this package of data, the seed part file, the database, that's all used with the functionality of Driveworks Express to help you quickly build new part models. So, step one with Driveworks Express, and in my opinion and in my experience, this is the most important part, and that is to create a very robust model. You need to keep the variables in mind that you would like to control. You need to think about design intent, and the model needs to have a very robust design intent. Needs to be created in a way that you can pretty much change any parameter and you do not get any rebuild errors, because if the software wants to change it and you get rebuild errors, I think we can all agree that's probably not something we want to happen. So the model we're looking at here, here's what we came up with. So the important thing to understand is everything is really driven by this first sketch one, this layout sketch, where we've got the height dimension in there, the width dimension in there. We model in half of the door panel. Again, no dimensions on that sketch. It's all driven by relations in the layout sketch. Same is true with the representations for the 2x4 framing. One extruded boss at the top, a secondary extruded boss mirrored to the bottom. The vertical frames, they're sketched. A lot of relations to control the size. One dimension for the width, equal relations to make them all the same size. And then you'll see leveraging up to next, possibly up to body or up to surfacing conditions. We want the model to just update. That's kind of the goal when building this type of a part, because we don't want to have, again, rebuild errors. We want to make sure that we've tested it, that it's nice and robust, and then everything just simply works. The other thing that I'll point out in this model is every single sketch creates a single feature, which creates a single body. So it is a multi-bodied part. That might be optional, but it does give us quite a bit of flexibility when it comes to hiding bodies or deleting bodies, or in the example you can see here, mirroring bodies with a nice quick window to generate the other half of the, the double swing door there. So that's what we're looking to automate, different sizes, and running it through Driveworks Express. So once you have a nice robust model, it rebuilds wonderfully. You don't get any errors, and it does exactly what you need to do. We want to mark the variables, and we recommend naming them appropriately. Now, is it a requirement to name these variables? I will say no. But if you've ever done anything in SOLIDWORKS where you've worked with dimension names, maybe design tables, maybe equations, or you've worked with Driveworks Express, you've probably noticed that there are dozens of the D1s and D2s and D3s, and it can be a little bit confusing to discern what is what. So just take a couple of minutes and rename those important features, those important sketches, or those important dimensions. I can really help you out down the road. So all we're doing here is just simply selecting a feature in the tree. Either click F2 if you're familiar with that hotkey, or the click, pause the mouse, left click a second time to rename a feature. So every sketch dimension can be renamed, every feature dimension can be renamed, sketches, features, planes, the list goes on and on and on. So we'll go through and we will rename every single feature. Again, trying to make it as easy to use and as easy to understand for any other person that's going to interact with this model. And that's another thing to think about. I built this one time. I'm giving it to my company to utilize and to work with. So I want to make it as easy to use as I can. Step 3 is creating the Driveworks database, and this is where we must activate Driveworks if we have not done so already. Now in this example, we've already turned Driveworks on. We've already got our activation code. So we'll load the model up in SOLIDWORks. We start up Driveworks Express from the Tools pull-down menu, and really at this point, the only thing we can do is either create or change where we're creating and saving the database. So because we are building an Access database, we want to make sure that we put these files in a location that is static. We don't want to move them around. We don't want to accidentally delete them. We don't want them in any kind of temporary folder. Again, Driveworks Express needs this database and a link to the SOLIDWORKS part model in order to make everything happen. So that part, pretty easy. And I think you'll see as we go through the process of setting this model up in Driveworks Express, it is pretty easy to do. There's not that much to it. The hardest part of all of this, as we'll see, is actually naming the file, believe it or not. So now that we've created the database, let's capture the variables, those models, dimensions, features. Really, it's anything that we want to control. Now, we're not going to control every single parameter, dimension, feature of this model. We're just going to control a couple. And when you're starting off with any type of automation, it's always a good idea to start small and then build up. You know, you've got to get an understanding about how this software works, how your model works, before you decide to, quote unquote, automate literally everything. So here we're just adding in a couple of dimensions, the door height, the door width, and we want to control this particular feature. Now when we select features, this is going to give us the ability to suppress, to shut that feature off, or unsuppress it, again, to bring it back in there. And if you've ever built a design table, you may have noticed, wow, that's just like clicking a dimension and adding it into a design table, or just like clicking a dimension and adding it to a SOLIDWORKS equation. So again, not too hard to get through as far as Driveworks is concerned. So now we're going to create the form. And this is where we want to think about the end user experience. How much information do we want the end user to fill in? How many choices do we need them to make? For this part, we're just going to add in a couple of fields, and we'll give it names that are easy to understand. And we can specify what type of data is going to go in this field. So just text box or a numerical text box with, in this case, minimum appropriate values, maximum appropriate values. There can be check boxes to make choices. We can have drop-down lists. But we're just setting up a few parameters so the end user can control the width of the door, the height of the door, and we want to make sure that we have appropriate min and max values. We don't want the end user to put in some value, for example, they're not going to be creating a door that's 30 feet wide or anything ridiculous like that. Now, all of these units are in inches, so that would be way outside the bound of what we're typing in. But here's where we can get a little bit more, I'll say, interesting with our form. We can specify an option for the cross brace. Now, that's a feature in the tree. So we could specify a drop-down list, and we can have any number of yes, no, maybe, whatever the case is with the drop-down list. If that's a little bit too complex, maybe we just want a checkbox, essentially a yes or no condition. So there we can see we've put the variables, we've generated the form, and we can test the form very, very quickly. Now, testing the form isn't going to do anything as far as the model is concerned, but it does allow us to validate what we've set up. Here we can see we specify a value that's not within the bound, and it doesn't allow us to move forward. So even before we've set up any logic or rules, there are some rules to help us out. And speaking of those rules, that's where everything goes together. That's step 6. That's where we map our SOLIDWORKS model variables to our inputs in the form itself. As we take a look at the next step of the kind of Driveworks Express wizard, it does a rules check for us. We can see we're missing a rule for the file names, 2 for the dimensions, 1 for the features, and it adds them up, and we've got a total of 4 rules that we need to fix. So we'll go ahead and we'll just simply edit them all. Each one of these that we select, we can then go ahead and start building the rules. So this is the, I'll say, kind of complex part of Driveworks Express. This is where we need to think about what do we want the software to do for us. We can put in various inputs, logical operators, mathematic operators, and we can get very, very clever as far as the end result is concerned. So what we're doing here for the 2 dimensions is just simply linking this parameter to the dimension in SOLIDWORKS. So this is really, really easy. A simple equal sign is all we need, and we can go ahead and just link it up to the input of, in this case, the door width. As we add the rules, they're eliminated from the list, so we'll only see the rules that are needed to be filled out. Now this rule for the cross brace, this is going to get a little bit more interesting because we're going to set up an if-then-else statement. So if the cross brace is true, that checkbox is true, then we are going to have that cross brace feature in the model itself. So it's going to use the unsuppress function, just like suppressing and unsuppressing a feature in the tree. If the cross brace is unselected, then we will again suppress that feature. So you can set up, basic if statements or much more complex logic statements in your Driveworks Express environment. Now this final rule, this is the most complex rule that we're going to set up here, and that is to name the file. So we want the name of the file, the new model that Driveworks Express builds for us, to be a combination of all the parameters. So we're going to start off with having the parameter of the door height, and then the X symbol, the door width. It's kind of hard to see there, but that's actually a space in between the quotes. And now we're going to add in a final if statement, and it's going to be dependent again on that cross brace checkbox. So if that cross brace checkbox is true, if it's checked, we want to append the file name with the following text, with the brace. If it is not true or unchecked, we want to append the name with no brace. Notice as we're typing out there, that field was red. That let us know we have not satisfied the requirements of that rule. Once we fill the requirements out, everything is no longer red, and we're good to go. So all that data will be brought together, and that's going to generate our file names. So in the end, the file name was kind of the most difficult thing to do here. Now that we go back to the summary, we have no rules left hanging, and we're ready to actually run the environment. And that's the final step of this process. Test and then implement it. Test your variables and try to break it. Try to imagine any potential option, any variable, and key it in there, because from my experience, if I don't think about it, somebody else will, and then someone else will break my model. So really try to think about creating the most robust and the most robust set of variables as well. So let's see how this all goes together. Pretty simple. We're not doing a lot other than adjusting the width and the height and making a choice of the cross brace. So there we can see a height of 100 inches, width of 125, and the cross brace should stay there. So nice wide door, get a good size lawn tractor in and out of our shed, no problems right there. So we can see everything worked appropriately. We didn't get any X's in the Driveworks Express interface. There's no errors. The model didn't fail. Everything looks as expected. And the name of the file, shed door, again, the width, the height, the height, the width, and the width brace. Just another example. See how it works. We'll toggle the brace off, create the model. It'll do its thing. You can see temporarily the seed model is opened up inside of SOLIDWORKS, and then the geometry changes. So pretty easy to understand exactly what's going on here. Just takes a little bit of practice to test it out. Make sure that the model, again, I know I've repeated myself here probably a half a dozen times, but you just want to make sure that that model is robust and can handle those rebuilds. Any parameter that's out of range, it does not let you go forward. So you can only enter what the developer of the Driveworks Express interface says we can enter. So it's all about an easy way to create those, again, same but different designs. You wouldn't want to take your wooden door and try to make Driveworks Express turn it into the shed itself. Just think about simple variables to modify. So the next tool we want to touch on is DFM Express, Design for Manufacturing. So this is going to check your parts and make sure it's quote-unquote manufacturable. So it's going to validate milled parts, turned parts, molded parts, formed parts, help you avoid wasted material and time, help you avoid any potential mistakes. And again, it's free. You have access to this software. You may have never heard about it before, but we'll take a look at it. And what we're going to do is just take a look at the manufacturability of the hinge. So we're going to get into the business of manufacturing the hinges as opposed to just buying hinges for our doors, I guess. So like the other tools, DFM Express, it is built into the task pane on the right. And in the end of it, there isn't much to DFM Express. We choose our options, and then we specify the parameters and the essentially dimensional checks that the software is going to do for us. So there we can see the different selection radio buttons there, and then the different checks. For example, percentage of the whole area inside the part, minimum tool depth to diameter ratios. More than the other tools, DFM Express really requires a good understanding of the manufacturing process, because if we give the software, I'll say kind of bogus values for these parameters, well, that's how it's going to check our part. Create a model, start DFM Express. That's really all there is to this particular Express tool. So here's our sheet metal hinge. We can flatten it out so you can see the basic shape of the geometry, but there's not a lot to it. 3 countersinks in there, simple little sheet metal part, and we want to check, again, the manufacturability of this particular part. So we can go ahead and start up DFM Express, and we can take a look at its interface. We don't really have any checks to run. We can look at the settings, we could shut it down, or start off with the help. So this will load up the SOLIDWORKS help, and all the Express tools have useful help associated with them. So if you need to check a little bit more information, you could see exactly what these tools can and do. That's really the most important thing, understanding the bounds that we need to work within. So as we switch over to the settings here, we can see that it's a mill or drill only, a turn with milling and drilling, it's a sheet metal part or an injection molded part, and the parameters that we can modify for each of the 4 processes, and we can go ahead and just cycle through them. Most of these are really looking at the diameter of the holes to the depths of the holes, or the position of the holes relative to model edges. Here we can see injection molding is really looking at wall thickness parameters more than anything. So not super sophisticated, but it does give you a good understanding about what's going on here. Step 3, adjust your settings and run. Switch model configurations if you need to. You can suppress features, unsuppress features. It totally supports those standard type SOLIDWORKS operations. And that's what we're going to take a look at here. We could run the sheet metal part in the bent state. We could run it in the flattened state. Now it may have dramatically different impacts on the manufacturability if it's a flat sheet metal part versus the bent sheet metal part, for example. But we want to take a look at the hole parameters, or the milling and drilling aspect of this. So you can see the tooltips do help us out a little bit. They give us some additional information about what each of these parameters represent. But again, we do need to take that upon ourselves to truly understand what a hole depth to diameter ratio means and what's appropriate for our part. We can modify the standard and acceptable hole sizes. We can really filter that table out. And using those parameters, we can see that we run it on this part and we have two rules that fail. So basically, this check is trying to mill out those internal notches. And it's not a big fan of sharp internal corners, which makes sense. A couple different ways that we could approach that if we were going to mill the profile of this model out. This check is also not a fan of the fillets on the outside edges. So potentially we could replace those with some other type of model geometry that may be a bit more appropriate. So right inside the environment of, even with DFM Express running, we can go ahead and add some fillets to those inside cutouts. They don't have to be much. This isn't a very large part otherwise. We can just go ahead and select the two fillets on the upper cutout, the two fillets on the lower cutout, because I guess we're going to machine our hinges from billet or something along those lines. And here's a cool little trick. In case you've forgotten, you can right-click on a fillet and convert it over to a chamfer. No need to delete and recreate features. So there we've flipped those fillets to chamfers, and we can rerun the check, and everything is good to go. So 10 checks have now been passed at this point. So really quick, kind of a go, no-go type of tool utilizing DFM Express. So the third Express tool we are going to take a look at here is Simulation Express. Now in my experience, Sim Express, as I like to call it, a lot of users know about Sim Express. It was the very first Express tools. It has been around for much longer than the others. And this is all about running a first pass, kind of simplified linear static analysis on your parts. It does only support single body parts, no assemblies, no multi-body parts. But it does allow us to run a true linear static analysis, and therefore we can take a look at stresses, displacements, factor of safety, get a jump up on any type of avoiding early physical testing, things like that. And also, just like all of them, it is free. So we'll utilize our newly modified hinge and just make sure that it can survive anticipated loading conditions. So step one, open or create a model. Now, Simulation Express doesn't actually require native SOLIDWORKS features, so this could work just fine on any type of imported geometry, as long as it's a single solid model body. Turn on Sim Express and essentially walk ourselves through the analysis wizard. You'll sometimes see it referred to as the Simulation Express or the Sim Express analysis wizard. And there we can see it even has that wizard look and feel with a next button to walk us through the process. So what's kind of neat about Sim Express is it does have a link to some pretty useful web training and little videos that maybe give you more of a background on linear static analysis inside of SOLIDWORKS using the simulation tools. Talk about loads and boundary conditions and the very important assumptions that linear static analysis makes in order to solve these types of problems. And it even has a couple of exercises that you can work through to practice. The options are extremely basic, your unit systems and where the results are going to be saved, as well as a checkbox to show the annotations on the plots. And we'll see those once we actually run the study itself. So at that point, we're ready to, as I like to say, just kind of next our way through the Simulation Express environment. And that next step is to add the fixtures or connect it to the outside world. Now the hinge is not going to work in a vacuum. It's going to be bolted to the door. It's going to be connected to the other half of the hinge with a pin. So the fixtures are the best way that we can simulate, again, that outside world, those connections in there. So we can apply fixtures to faces on our model. So they are going to be fixed geometries, The thing to understand about a fixed boundary condition in Simulation or Simulation Express is those faces are now perfectly and infinitely rigid. There will be no deformation on those surfaces, so it is quite common to have some stress concentrations right at that boundary, those edges from an infinitely rigid face to a ductile face, so just keep something like that in mind. So that's really all there is to adding the fixtures. We just need to keep it from moving around in the modeling space. The next step, apply the loads, and where's that force going to be applied? So like the fixtures, we can apply our loading conditions to faces. Now those loads could be either a force or a pressure or a combination of the both of them. We can add any number of either normal forces or forces relative to a direction on our models. We could combine that up with various pressures. So there is quite a bit of flexibility as far as the loading condition is concerned, as long as it's appropriate to apply the load to a face. No edge loads, no point loads, nothing like that. So now we're going to switch the load from a normal force to a force relative to the reference plane and a force of 100 pounds. Just be careful when you're applying forces. There is a checkbox that will determine is this a per item force or a total force. In this case, it is 100 pounds per selection. So we can add that up pretty easily of 300 pounds total force being applied. That's a pretty common error that happens in the setup of not just Simulation Express, but regular simulation as well. Step 5, apply the material. Now, if you're really good about applying your material to your SOLIDWORKS part models, well, SimExpress will pick up on it, and the material will already be utilized. In this case, we did not do that. So we need to go ahead and choose a material. And this will load up the SOLIDWORKS material library. We're all familiar with this, I would imagine. Simulation, SimExpress, SOLIDWORKS, they all use the same material library. So if you've created any custom materials with custom parameters in there, you can leverage those as well. So pretty easy to go ahead, add the material. And again, we just kind of next our way right through the SimExpress environment. Step 6, run the study, verify the results. And by that I mean, does it behave the way you think it should behave? If it's displacing in some completely unexpected way, you might want to double check your loads and boundary conditions. Also here, we can generate a report. A very simple, but it's an effective report, all formatted inside of Microsoft Word for you. So this part of the process is the easiest. We click Next and we say Run Simulation. So this is where we're going to mesh the part, where it's going to run a linear static analysis, and then it's going to show us a really quick animation about the exaggerated deformation. And that's another thing I want to emphasize here. The deformation scale in this example is 4.4 times reality. So tends to look a little bit strange if you're not ready for that. We can see here that when we click Yes, we get a pretty disturbing plot. This is a factor of safety plot. But first, let's interrogate the von Mises stress. And what's a little bit unnerving here is our yield strength arrow, shown in red, is clear down at the very bottom of our graphical gradient. So that means we have stresses well beyond the yield strength of the material. So essentially our results are null and void. This is a linear static solver. When you go beyond yield, it's just continuing that linear stress strain curve. So you want to be really careful about digging too deep into the results beyond the yield strength of the material. We can see the estimated minimum factor of safety is actually 0.068, and a large volume of the model is going to have significant failure due to yield. So yeah, the hinge is probably going to fail based in this loading condition. So we can generate a report. We can add descriptions and put in all sorts of other information in there. Our conclusion is very profound. We need to thicken the material. But again, it just gets us started. So in the background, while the generating report window is up, you can see that the view scale is changing. It's zooming to fit, things like that. The software is automatically gathering all the inputs from our little Simulation Express analysis, taking screenshots of it for us, and it's going to format it automatically in a Word document. Word will load up. We can see we've got a nice cover page here. We've got a table of contents, screen pics of the model, the geometry, the volume, the material properties, etc., etc. So it does a lot of the, kind of grunt work, if you want to call it that, of formatting all this important information into this report. This really eliminates the copy and pasting that one would have to do, or the potential error in data entry if we mistype a number or anything like that. Now, each one of these pages, there are text fields below. We could add in other comments, anything else that we need to. But here, again, we get to the end. We can see our conclusion. We need to thicken the material. So just another option that we have as far as utilizing the Simulation Express software. So what do we do now? Well, now we make changes. And I like to say we make informed decisions. We know how the model is behaving. We understand the response. We know where the high stresses are. And now we can go back into SOLIDWORks, modify the geometry, rerun, and again, verify those results. So this is the case where we're very hopeful that the change we make drops our stresses, increases our factor of safety, and everything starts to get much, much better. So this little iterative circular approach that we're doing here is what what Simulation Express is really, really useful for. Same materials, same basic geometry, same loads and boundary conditions. Maybe we want to test out a couple of different wall thicknesses or something like that. Really quick, easy way to get a better understanding about our design. Here we can see with a desired factor of safety of 2, right in the loops of our hinges, we've got a minimum factor of safety of 1.3 roughly. So while it's not failing, we may want to make some other changes to see if we could increase that a little bit more. So it's all about learning, better understanding the stresses, displacements of our part. Again, so we can go ahead and make informed changes. We could change the model all day, but are we changing it for the better or are we changing it for the worse? That's where these Express tools kind of come into play, help us make those changes always for the better. And last but not least is FlowExpress. So this is a first pass fluid flow. So you have actually computational fluid dynamics capabilities for simple conditions built right inside of SOLIDWORks. So this is going to allow you to visualize either air or water flowing through your parts or assemblies. Does have some pretty noticeable limitations where we can have one inlet, one outlet. Can't have multiple fluids, multiple liquids or gases mixing or anything like that. Air or water, again, pretty basic to get an understanding about what's going on inside of the geometry. And what we're going to do is verify the flow through the good old water spigot. So open or create the model. The condition, 1 cavity. Again, 1 entry, 1 exit in here. Now, just like Simulation Express or SimExpress, FlowExpress does not require that this is native SOLIDWORks geometry. Its only requirement is it's an enclosed volume. So here we can see our little faucet there, our little valve, which is actually backwards as we rotate it around. We open the valve, but the handle is now perpendicular to the flow axis, which is kind of strange. But that's what we're really looking at calculating here. We want to observe the flow through this valve, and we could run the analysis at any variation of angle, whether it's mostly open, mostly closed, anywhere in between, and we could just take a look at it that way. So there's the model. Second step, and this is really a requirement for any type of flow study, and that is to cap the inlets and the outlets. We build what we like to call lids inside of Flow Simulation and FlowExpress here. So this doesn't make any difference if it's the FlowExpress version or full-blown SOLIDWORks Flow Simulation. This step is mandatory. So what we're going to do here is just create a couple of parts, capture some edges, do a little bit of convert entities, and create some very simple extruded bosses. I'm going to put a lid at the end on the left, and then a lid at the end on the opening side of things. So the reason we need to create these lids is we need to have a completely enclosed volume so the software can calculate that flow volume for us, and then that's where we will visualize the fluid flow through the assembly. Even if this is a single-bodied part, again, we need to make sure that we essentially plug the holes so we can apply our boundary conditions to them. We could do that easily on an imported part just like we're doing here on native solid geometry. Now we'll turn on FlowExpress, and the first thing it will do is validate whether or not the part or the assembly is suitable. So it does a little leak check, I'll call it that, just to make sure that, again, it is completely enclosed volume. There's no forgotten gaps. I didn't miss a lid or anything like that. And we can see really quick it loads up, and it actually does the leak check automatically. The geometry is okay. The one thing that kind of catches me out about FlowExpress is typically when things are acceptable or they are quote-unquote okay in SOLIDWORKS, the little message window turns green, but this one stays yellow, which I've always thought is kind of odd. Here we can view the flow volume. That's what the volume looks like when the valve is closed, which I think we will all agree is not the most exciting thing. So we'll go ahead and we'll just close out of this, and let's open the valve up. Now we're going to open the valve 100%, but you could open it any angle in between and take a look at what that flow looks like as that valve kind of progresses open to close. So there we can see the modified fluid volume. Like Simulation Express, FlowExpress just has a wizard where we'll click Next. We'll specify what type of fluid is passing through our assembly, and then we'll go ahead and then calculate the various inlets and outlets. So that's really where we are as far as step number 4, set the inlet and outlet boundary faces. This is where you're going to leverage those caps, and it does help to hide that outer body because it's very important to select the inside faces of the caps or those lids that are in contact with the flow volume. If you don't do that, you will get an error message, and that's, again, fairly common. Step 5, set up your boundary conditions and run. So steps 4 and 5, that's all kind of part of the same process. So we'll go ahead and we'll just step through these here real quick. So the inlets and outlets, fairly basic. You could have pressure inlets, volumetric flow rates, mass flow rates. And once we specify the inlet, well, then we're only going to be able to have, a pressure for an outlet. So again, fairly basic as far as the in conditions are concerned or the boundary conditions. Here we can see we've hidden that outer body to make sure we select that inside face. And then finally, we'll select a pressure opening and specify an appropriate pressure. In this case, environmental pressure to simulate the water just opening up to the outside world. After that, we'll go ahead and solve. Now this can take several minutes or longer to solve because it is running an iterative computational fluid dynamics solution. So be patient, especially if you have a much larger assembly and still one inlet and one outlet, but you could have a much more complex internal geometry setup, internal flow field as well. So that might take a while to solve. So as far as the results are concerned, we can see we've got options to take a look at the velocity plot through our assembly. We could visualize the velocity kind of originating at the inlet surface or those pipes exiting, selecting the outlet surface. So that's what's representative by the inlet button and the outlet button. It's just where we're visualizing those pipes beginning or ending there. Switching it over to the little spheres, this gives us an interesting animation, helps us better understand what's going on internal. So we'll switch it over there, we can see the difference. But we'll go ahead and just animate these. And this is going to allow you to visualize eddy currents or stagnation areas, anything like that. Maybe not critical with a water valve, but if we had any type of electronics cooling situation, we need to make sure that we've got appropriate airflow through there so parts of the electronics don't overheat or anything like that. FlowExpress has a very similar report tool, so we won't go through it, but we can grab any kind of snapshot view up on the screen, and we can then go ahead and generate the report. So all this data, just gets saved inside the assembly file, and you send it along and visualize it in a number of different ways. So FlowExpress, again, simple tool to visualize the flow throughout your design, whether it's a part or an assembly, native or imported, it really does work the same. So that's where we wrap up as far as our Express tools are concerned. Covered all 4 of them, kind of hit the high points, what they can do, what they can't do, give a good example of their functionality. So with that, I want to end it on a big thank you. I really appreciate everyone showing up now this afternoon in most parts of the country. If you've got any questions or comments or suggestions for webcasts, we're always looking for new ideas. We're planning out next year's webcast, what we want to talk about. If there's anything you're interested in or you'd like to see, send them to my email address. We'll see if we can make it happen for next year. So again, thank you everyone for joining us today. Keep an eye out on the CATI YouTube channel for the video. It'll be uploaded here in a couple of days. And with that, hope everyone has a nice rest of your day.